Imagine that you're in a modeling activity, and in your modeling activity you observe that the function you can use for your process could be a line. So in this case, you can represent your observation as a linear function. Now the question is, how can I represent a situation using a linear function? So in this video, we're going to see what is the gradient, how to calculate the gradient, and how to represent a linear function. Let's go to the board and let's observe how to get the linear function. So if you want to get a linear function, so any linear function is a function of the form mx plus b. Or maybe you know that it's also y equals mx plus b. You know, this is the function notation. This is the coordinate notation. Now, what do we need? We need to have the m, that stands for the gradient or the slope, and we need to find out b, that is the y-intercept. Now, the y-intercept of the linear function is just the place at which your line crosses the y-axis. So this point that is here, that in coordinates will be 0b, is the y-intercept. So if you have a graph of a linear function, the only thing you need to know using the graph to find out the y-intercept is to check where the line crosses the y-axis. This is the y-intercept. And the gradient or the slope is calculated by using the change, or what people call rise over run. What means rise over run? So we're going to measure the distance that my line rises between 2 points, and I'm going to divide it by the distance that my line runs or moves on one line. This could be expressed in coordinates at y2 minus y1 over x2 minus x1. This is because this will be the point x1 y sub 1, and this will be the point x2 y sub 2. And this is how you can represent the gradient of a linear function, just with the rise and run, or the change of y with the change of x. Now, to find out your linear function, what we need to do is just to identify the information we have. So how could I use the information I have to get a linear function? In plain terms, and as you can observe from the graph I did, the scratch of graph I did, is that you just need to find out the linear function if you have 2 points. So if I gave you 2 points, you should be able to calculate the linear function. You should be able to find out the linear function. Let's see an example. Let's say that my line passes by the points -2, 1, and the point 3, 7. Okay, so I'm going to find out what is the linear function that accomplished with this situation. Okay, or what is the linear function that passes through this point? Maybe you're modeling something, you know that the train should be linear, so you're just going to take 2 points on your line to calculate your linear function. So first we're going to use the equation for the gradient to calculate the gradient. So m equals, now I just need to name, this will be, for example, x1, this could be y1, this will be x2, and this will be y2. Hey, you need to be careful, because when you calculate it, it's good that you organize information in order. y2 minus y1, x2 minus x1. Don't subtract different parts. So in this case will be y2, 7, minus y1, 1, x2, that is 3, minus 2, that is x1. Okay? Now 7 minus 1 is 6. 3 minus 2, this is 3 plus 2, so it could be 5. So my gradient is 6/5. Now I know if I find out the slope, I know that my linear equation or my linear function is going to be y 6/5 of x plus b. Now, the problem is to calculate this term. I'm going to put it in red, b. How can we calculate this term that we call b? Now, if you want to calculate the term b, we can use any of the points that I have in my line. If I use any of these points here, I should be able to calculate the y-intercept b. What I recommend you to use the easiest point you can. The easier point you can, select it. For example, I have here a -2 and a 1, a 3 and a 7. I prefer to use a small number, so I'm going to use this -2 and 1. So in this case, I'm going to select the point -2, 1. So when x is -2, 6/5 times -2 plus b, y should be 1. And now I'm going to solve the expression. So it's going to be 1 equals, so to multiply these two fractions, so -6 times 2 is -12, 5 times 1 is 5, plus b. Now I'm going to solve by adding by 12/5, so 1 plus 12/5 equals b. And I just need to add these fractions. Remember that 1 could be expressed just as 5/5. So 5 plus 12 is 17/5. That will be b. And the equation of my line is going to be y equals 6/5 of x plus 17/5. So that will be the equation of the line. Or in function notation, fx equals 6/5 of x plus 17/5. And this is how you can get the equation of the linear function. So observe that in the equation of the linear function, I just need to have 2 points, and with my 2 points, I can get the gradient or the slope using the rise over run formula. I mean, the change of y over the change of x. This is the first step to find out your linear function. And then, if you want to find out the y-intercept, you can just use one of the points with your new equation to determine the y-intercept. This is the algebraic form. The other way will be that you graph the function, and by graphing the function get the y-intercept. However, in the case that I show you here, it's difficult to find out that the y-intercept is 17/5 by using a graph. You should do like a really very good graph to find out your answer. And this is how you can get the linear function from 2 points, and this is how you can get the y-intercept form or the slope-intercept form of a linear function. In the next video, we're going to see how to get the other forms of linear functions. So I hope that this video helped you. I hope that you like it, share, and I let you as a homework so you can practice, so you can tell me if you understand. I let you that please find out the line or the line no. Find the equation of the line that passes by 3, -2 and 5, -4. What will be the equation of this line? Find the equation of this line, put it in the comments, and let me know your questions because I will answer it. See you in the next video. Bye bye.